Assalamu alaikum. We have obtained the expression for de Broglie wavelength of matter waves in the previous video. In this video, we will get the expression for de Broglie wavelength of electron. For that, I consider an electron with charge E and accelerated through a potential difference represented by letter V. If it is so, the kinetic energy possessed by that electron is represented as K, and it is nothing but the product of charge E and the potential difference V. This is taken as equation number 1. Now, we know there is one more expression used to represent the kinetic energy. Notice that, let me write this one here. Kinetic energy is also represented as half mv square. This is taken as equation number 2. Here, small v represents the velocity with which the object is moving. In our case, it is nothing but electron. And here m is the mass of the electron. Okay, now here we have two equations. Now I am going to equate them as the terms on left hand side on these two equations are same. So it can be equated. I'll take it this way. Half mv square equals to EV. Now, before going ahead, I will going to find out the value of velocity with which the electron is under motion. So v square will be equal to, I take the remaining term to the right hand side. What I will get when 2 is taken to right hand side, it will multiply. So 2EV and m will divide. This is what we get. Now from this, V value is obtained by taking root 2V upon m. Now this capital V, I take this as equation number 3. Now my aim is to get the wavelength, de Broglie wavelength of electron. What is the expression for de Broglie wavelength of matter waves? Wavelength is represented by letter lambda, and it is nothing but h upon mv. Here, when you multiply mass with velocity, you get momentum. The ratio of Planck's constant and the momentum is nothing but wavelength. This is taken as equation number 4. Now, before going ahead, let me tell you what is the wavelength. If I consider this one as a wave, then this portion of the wave is referred as crust. And this is referred as trough. The distance between two consecutive crusts or trough is referred as wavelength. So here, this is the first crust and this is the second crust of this wave. These two are consecutive crusts. In a similar way, this is the first trough and this is the second trough of this wave. Now, if you measure the distance between these two consecutive crusts, then it will provide us the wavelength. In a similar way, if you take this distance between these two troughs, then again it represents the wavelength. I hope I have understood what does wavelength mean. Now, I will obtain the expression for wavelength of electron from equation 3 and 4. Now I'm going to substitute the value of V in equation number 4. Substituting 3 in 4. What do I obtain if I do so? See, lambda equals to h upon m. Here, the place of V, I write equation number 3. Root of 2e capital V upon m. Now, for my convenience, instead of writing this one as m, I write it as root m multiplied with root m. H root m multiplied with root m. Then remaining terms written as 2ev upon m. Here I can do one more thing. Instead of writing this as the root of 2ev upon m, I write this as root of 2ev upon root of m. If I do so, it is not going to change the values. Now, this root m and root m get cancelled. And what remains here is nothing but root m multiplied with root of 2ev. Now, h divided by I combine these two parts. So I get root of 2m ev. This is what I obtained. This provide me the wavelength of electron. So lambda equals to h upon root of 2m ev. This is the final expression. I can simplify this to some more extent. How? Here ev is nothing but kinetic energy of electron. So in the place of ev I can write k. So in the next step, this can be written as lambda equals to h upon root of 2m k. I box this for better visibility. This is the final expression which gives us de Broglie wavelength of electron, moving electron. Correct? I take this as equation number 5. Now, here h stands for Planck's constant and m stands for mass of the electron and E stands for charge of the electron. And the capital V is nothing but potential difference through which electron is accelerated. If we substitute the value of all these things, one can easily obtain the wavelength. Now, I am going to do that. Lambda actually is 6.623 into 6.626 into 10 power minus 34 joule second divided by root of, I take V here, material 2, write the value of mass of the electron. It is nothing but 9.11 to 10 power minus 31 kilogram, and charge of the electron is 1.9 into 10 power 1.6, I'm sorry, 1.6 into 10 power minus 19 Coulomb. So there we have shifted to this part. Now take root of all these things. If I do so, you get that. Now, the value obtained to be equal to 12.127 into 10 power minus 10 meter divided by root V. Okay, here 10 power minus 10 meter is referred as 1 angstrom. How do we represent angstrom? You see, this question can be written as 12.127. angstrom root of V. This is the final expression to know the wavelength of electron when it is accelerated through a potential difference V. Okay, here let me write this. 1 into 10 power minus 10 meter is equal to 1 angstrom. I hope the video is useful. If you have any kind of doubt related to the topic, kindly put your question in the comment section. Thanks for watching.